Okay, so today we're going to talk about the fminbnd function, and precisely what the fminbnd function does is it gives you x and y values at which, or x and y value at which local minima occurs. From calculus we know that it's not the overall it's not global minima or the overall minimum value in the function for a graph or for a function. So it will, since it's local, it will require a range that you give it a range, and it will look between that range to find the lowest value. So the general format for the fminbnd function is you have on the left hand side inside brackets you have two variables. The first variable you can obviously can name it anything you want, but what it will do is it will give you the lowest or the x value at which the local minima occurs, and then the second variable will tell you the y value at which the local minima occurs. So that's what you have on the left hand side. It's assigned the fminbnd function. You write fmin and then you write bnd for fminbnd, and inside the fminbnd function the first thing you write is the function handle, and then comma, and then you write your range. So the first thing for that you write is the lower bound, and then comma upper bound. So you're telling MATLAB that here's the function, and then between this range or these two x values, find the lowest point or the value, the lowest y value for these x's, or between these x values. So here, for example, you have x is assigned linspace -5, 5, 101, and your function here is f is your function handle is assigned x squared minus 5. So your function here is x squared minus 5. And then we know what that function looks like, but I already graphed it if you don't remember what it looks like. So here you see that this is the function. It's just the normal quadratic function shifted down by 5 units. So from this, before we actually code the code using the fminbnd function, we should look at this graph and then really see or think about where the minimum values occur. So if you look at this graph right here, we see that the minimum value or the local minima occurs at 0 for x value, and then -5 for y values, if we call this your x-axis and this is your y-axis. So it occurs at 0, -5. So it's good to have an idea of what you should get as your answer beforehand. So here we'll write, I'll keep my variables same for now. I'll call it x value and y value on the left hand side. Once again, this is where this is the x value at which local minima will occur, and this is the y value at which the local minima will occur. So that's on the left hand side. It's assigned fminbnd function. Here we have our function is f, or our function handle rather is f. So you can write f. You can either write that or you can write this whole thing if you want, but it's better just to write that since I already assigned it. And then we know that the local minima occurs between -5 and 5. So what you can do is you can just write -5, 5. What this will do is it will, when you run the program, it will give you 0, -5. So 0 is your x value. We'll use a graph to confirm. So 0 is your x value at which local minima occurs, and then at that point, your y value should be -5. And we see that that is right. So that's all you need to know for the fminbnd function. It takes in a function and then looks between two ranges for the lowest value. If you have any questions about anything related to fminbnd function, let me know. Thank you for watching.